Hello friends, this is Animals and welcome to the GATE mantra. So in this video we are going to see or we are going to deal with the new chapter, that is combinational circuit. So in combinational circuit, what will be our approach? So in this we are going to first see the numerical, and then we are going to see the concept which are related to that numerical. So here in the combinational circuit we are going to start with the multiplexer. So we will read first multiplexer because it is important for the exam. Okay, so uh, let's see the block diagram of the multiplexer and how it's work. So suppose this is a 2 into 1 multiplexer. Okay, here one signal I0, here one signal I1, and here we are going to take the output, and here we are going to take the S conditional signal or selective signal. Okay, so generally how it's work, how the multiplexer works, we are going to see. So before that, let's see the another things that how it's working. Okay, so here is I0 and here is I1, and here are our output Y0. Okay, or Y. So suppose that there is a two and there is a key. Okay, that is there is a key. Okay, or switch S. Okay, and it's take the two level 0 or 1. It will take the two level 0 or 1. So when we are going to press the 0, okay, when we are going to press the 0, then it's connect to this line. It's connect to this line. Okay, this line. So when we are going to press the 0, then I0 will be go through this, and I0 will be present here. I0 will be present here. Okay, and when we are going to press the 1, then this line is connect to this I1, and the output will be I1. Okay, so this is the simple circuit where it's act as a switch. Okay, there is a switch, when we are going to press the 0 on this I0 line will connect to the output, and when we are going to press the 1, the I1 line will be connected to the output. So here let's see the another example. Okay, here let's see the I0, I1, I2 and I3. Here is our the one line, that is Y. Okay, now see, here we are going to consider the two switch. Okay, the S1 and the S0. So when there is a one switch, there is a two possible value. It will take the two possible value, either 0 or 1. And when there is a two switch, then it will be going to take the four possible value, that is 0 0 0 1 1 0 and 1 1. Okay, so when we have pressed the both key 0 0, okay, then I0 will be selected and it will be the going through to the output Y0. Okay, when we are going to press the 0 1, okay, then I1 will be select and it will be going to the output. Now it will be reject. Okay, when we are going to place 1 0, okay, then this I2 will be going to selected. Okay, and this will connect to this. Okay, now when we are going to press the 1 0, when we are going to press the 1 1, then this I3, will be connected to the output. Okay, so for 0 0, I0 will be connected to the output, I0 will be go to the output. For 0 1, I1 go to the output for 0 for 1 0, I2 will be go to the output, and for 1 1 for 1 1 I3 will go to the output. So when we are going to see this, okay, when we are going to see this, so we can make assumption that, or we are clear that what is the multiplexer do. So we can say that it is, we can say that it is many to one converter, many to one converter, because it's taking the many input and it's giving only the single output. And we can also say that it's many to one converter, because it's going to take the many inputs and it's going to give only the single output. Okay, now it can also say that parallel to serial converter, how, why we are going to see that it is parallel to serial converter, because by using any, okay, any value we are going to give here 0 1 0 and 1, we are going to give this value to the input, and the output is going to take the one value at a time. So when the switch will be 0 0, then 1 then 0 will be present at the output according to this input. When 0 1, then this 1 will be present at the output, and when 1 0, then this 0 will be present at the output, and 1, the select key is 1 1, then this 1 is present at the output. So from here we can see that, or we can say that it is the parallel to serial converter. Now we can also say that it is a universal logic circuit. Universal logic circuit. Okay, it is a universal logic circuit. How we can say the multiplexer as a universal logic circuit? This we are going to see in the next class. Okay. Now first we will try to, first you will try to prove that how the mux is the universal logic circuit, and try by yourself, and if it will be not understandable for the you, then I will going to tell that how it's work as a universal logic circuit. Okay, so it is the many to one logic. Okay, it is a data selector that we know that it select the one input from the many inputs depending upon the selective input. Okay, now it's the universal logic circuit and it is parallel to serial converter. So how we are going to define the multiplexer? How we are going to define the multiplexer? So the multiplexer is a combinational circuit which are going to select the one input. Okay, which are going to select the one input from the many input depending upon a condition, and this condition will be given by the selective, okay, or selective lines. Okay, so what is the multiplexer? Multiplexer is a combinational circuit. It is a combinational circuit. It is a combinational circuit which select one input from many input. It is going to select the one input from many input depending upon selective line. Okay, so what is the multiplexer? Multiplexer is a combinational circuit which are going to select the one input from the many inputs depending upon the selective line. So there are the different type of the multiplexer. Okay, 2 to 1 multiplexer, 4 to 1 multiplexer, 8 to 1 multiplexer. So we have seen that. Okay, when there is a 2 line and when we are going to give the one input, so here is only one switch. When there are 4 line, then this 4 line, when we are going to give the 4 data. Okay, and here is the output y, here is the output y, this is the input, this is the input, this is figure 1, this is figure 2. So here we are going to give the two switch S1 and S0. Here we have given the only one switch S. So when there is a two switch, then there is a 4 input. Okay, when there is a two switch, then there is a 4 input. When there is a single switch, there is a 2 input. So for n switch, or we can say for n selective line, for n selective line, how many number of input? That is 2 to power n input. Okay, that is 2 to power n input. For n selective line, there will be 2 to power n inputs. Now we are going to see the 2:1 multiplexer. So here we are going to see the 2 to 1 multiplexer. So this is its block diagram. Okay, here we are going to give the two input I0 and here I1. Here we are going to take the single input depending upon the selective line. So what will be its truth table? Okay, here is I0, I1, sorry, not I0, I0, I1. What will be its truth table? Let's see here. Here will be S and here will be Y. Okay, so when the S will be 0, when the switch will be 0, then this I0 will present on the output, then this I0 will present on the output, and when the switch is 1, this I1 will be present at the output. So when switch is 1, this I1 will be present at the output. We have seen already that. Okay, this is I0 and this is I1 and this is switch Y. So if switch is 0, if switch is 0, then I0 will be present at the output, and when the switch is 1, when the switch is 1, this I1 will be present at the output. Okay, right? So see here the logic expression, how we are going to see the logic expression. So from here we can say the logic expression, so when S will be 0, we are going to get the I0 as a output, and where the switch is 1 or S is 1, then we are going to get the I1 as a output. Okay, so here the logic expression Y will be equal to S bar I0 plus S I1, right? I don't think here it will be the confusion, because we know how we are going to get the logic expression from the truth table. Okay, now let's see the how we are going to get the logic diagram. Okay, logic diagram. So here we are going to give the I0, here we are going to give the I1. Okay, and here we are going to give the switch. So when switch is S bar, so here let's so S bar, okay, here it will be S bar. Okay, so let's make here, or we can say here from here S bar, and then I0, and then I0. Okay, NAND gate. Okay, and then S and I1. Here is one more AND gate. Okay, and here we are going to use the OR gate. This is the so here it's coming S bar, and here it's coming I0, and here is S bar I0, and here S and I1. Okay, and here the S I1, and we are going to give the multiply S bar I0 plus S I1. Right. So now we are going to we have seen that this 2-to-1 multiplexer. Now we are going to see the 4-to-1 multiplexer. Okay, now it's time to see the 4-to-1 multiplexer. So let's see the first block diagram. Okay, here we have the 4 input and single output. So here I0, I1, I2, and the I3, and here two selective line S1 and S0. Okay, and remember this S1 is MSB, and this S0 is LSB, and this is 4-to-1 mux. Okay, this is 4-to-1 mux. So now we are going to see the truth table. Okay, so for truth table S1, S0. Okay, this is the MSB, and this is LSB. Now we are going to see the output Y. Okay, so what will be the possible condition for two selected line 0 0 0 1 1 0 and 1 1? So when the switch will be 0 0 0 0, then this I0 will be selected to the output, then this I0 will be selected to the output when our selective line will be 0 0. Okay, so for 0 0 I0. Okay, when we are going to give the selective line as 0 1, then I1 will be present as the output for 0 1. So here for 0 1 I1, Okay, when we are going to give the input like 1 0, then this I2 will be present at the output. Okay, this I2 will be present at the output, and when we are going to give the input selected line as a 1 1, then this I3 will be present at the output. This I3 will be present at the output. So this I0 can take the two value either 0 and 1. This I1 will be take the two value either 0 and 1. This is also take the two value 0 or 1. So what will be the value of this I0, I1, I2, I3? This will be reflected to the output for the selective line, for the given selective line. Okay. Now from here we can write the logic expression as y is equal to the S1 bar and the S0 bar, S1 bar and the S0 bar, and this I0 plus, okay, this S1 bar and the S0 and I1 plus this S1 and S0 bar I2 and plus this S1 S0 I3. So this is our logic expression for the 4 into 1 marks, for the 4 to 1 marks, for 4 to 1 marks. Okay, so now we are going to see some example. Okay, we are going to solve some example that is really important for the GATE and the ESE. So our first example is, what will be the first example, that construct 4 to 1 marks using 2 to 1 marks. Okay, so for constructing the 4 to 1 marks, we need how many input? 4 inputs. Okay, 4 inputs, and here it's available 2 to 1 marks, means here we available the 2 inputs. Okay, 2 inputs, so we need the 4 input at the first stage, and we have only the 2 input available. So how we are going to create the 4 input? By using the 2 inputs, 2 to 1 marks blocks. So for getting the 4 input, okay, we have only these 2 lines. Okay, I0, I1, and here is switch bar. For using this we call the 2 to 1 marks. This we call the 2 to 1 marks. 2 to 1 marks. So for using 2 to 1 marks, we have to find the 4 to 1 marks. This is the 4 to 1 marks. And here is the 1 selective line, here is the 2 selective line, that is I0, I1, I2 and I3, and this is the Y. This is the 4 to 1 marks. So how many 2 to 1 marks is required for constructing this 4 to 1 marks? Okay, so first we need the 4 input. Okay, so for taking the 4 input, we are going to form this type of 2 to 1 marks. Okay, here we have given 0 1, here I2 and the I3. Okay, and here it's another output Y. Okay, Now this two output is coming from the 2 marks. These two output we are going to give to the one another marks, 2 into 1 marks. Okay. Okay, and here is the output. So what we will see, what we will tell, how we have, so where should we give the selective symbol? Okay, where should we give the selective symbol? So here remember, here we will provide the LSB, and here we will provide the MSB. Here we will provide the LSB, and here we will provide the MSB. Okay, so for this representation we can say that this is the 4 to 1 marks, this is the 4 to 1 marks, this is the 4 to 1 marks, using the 2 to 1 marks. So how many marks we are going to have to construct 4 to 1 marks in 2 to 1 marks is 3. Total 3 marks required, total 3. Okay, 2 to 1 marks required. So let's see how it's working. So for S1, S0, and what will be the this output y, we can say this is y0, y1 and y. So for S1, S0, 0, 0, so when here we will provide the 0, so it will select the first line, this is I0, so it will select the I0, and this I0, the input of I0 is the output of our upper marks, and when the S0 will be 0, and when the S0 will be 0, then it will select the I0. So here the input presented here will be reflected to the output, because when we are going to give S1 as a 0, then it will select the first input, and when we are going to give the S0 as a 0, it will also going to select the first input. So this input I0 will be present here, and this I0 will be present here. For what? For 0, 0. Always remember, this is the S1 MSB, and this is S0. For 0, 1, for 0, 1, so S0 will be, S1 will be 0. Okay, S1 will be 0, then it's again going to select the I0, and S0 will be 1, S0 will be now 1. Now it's going to select this I1, so I1 will be present here, I1 will be present here, and this I1, okay, will be present here for 0, 1. So similarly, when 1, 0, so this is the 1, so I1 is going to select, and this is the 0, so I2 is going to select. So for 1, 0, this I2 will be present here, and this will be present here. For what? For 0, 1, for 1, 0. Okay, and for 1, 1, we also can write here, and for 1, 1, so this is the 1, so it is going to select I1, and this is also 1, so it is going to select the I3. So I3 will be present here, and this I3 will be present here. So for 1, 1, this I3 will be present. Okay, so now see, by using 3 to 1 marks, we are going to get the 4 to 1 marks. Okay, so for 0, 0, for 0, 0, this I0 will be present at the output. For 0, 1, this I1 will be present at the output. For 1, 0, this I2 will be present at the output. And for 1, 1, this I3 will be present at the output, right? If you are feeling any confusion, then please stop the video, or please replay the video, okay, for better understanding. Now, so similarly, similarly, there is the second example. Okay, construct S to 1 marks, F to 1 marks using 2 to 1 marks, using 2 to 1 marks. So how you are going to construct that? So we need the 8 inputs, but here we have only the 2 inputs. So for getting the 8 input from 2 input, we require the 4 2 to 1 marks in the first stage. We require the 4 2 to 1 marks in the first stage. I0, I1, I2, I3, I4, I5, I6 and I7. Now we are going to get this 4 as a output. Now for taking this 4 output as an input, we require the 2 2 to 1 marks. Okay, we require the 2 2 to 1 marks. Okay, we require the 2 2 to 1 marks, and these 2 marks having the output 2 output. Now for taking these 2 output of these 2 marks as an input, we require the 1 marks here, 1 2 to 1 marks here. So all are digits 2 to 1 marks. Okay, now this is I0, I1 and I0, I0. We will write this is Y0, 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 Y1, Y1, and this is Y. This is the final output. This is the final output. So what will be here? Here will be S naught, okay, S naught LSB. Here will be having the S1 and here will be having the S2. Okay, so if we have to construct the 8 to 1 marks from using the 2 to 1 marks, then we require total 8 input at the first stage. So for getting the 8 input at the first stage, we require total how many marks? Total 4 marks. Okay, total 4 marks. And at the second stage, we require the 2 marks. Okay, in the first stage, we require 4 2 to 1 marks, and in second stage, we require 2 marks, and the third stage, we require 1 marks. So total we require 4 to 1, 4 to 6 and 7 marks. 7 marks. 7 which marks? 2 to 1 marks. Okay. So when for how we can see how we can construct 60 to 1 marks using 2 to 1 marks. So for getting 16 input, we require the 8 okay, 8 to 1 marks here, 8 to 1 marks here. Okay, total 8. And in the second stage, we require 4 to 1 marks, 4 to 1 marks. Okay, and in third stage, we require 2 to 1 marks, and last stage we require 1 mark. So total 8, 4, 2, and 1. 8 for 12 and 2 14, and in total 15 marks required. So from this way we can see, or we can find how we can make the marks of higher order from using the marks of lower order. Okay. Now, how we are using the mux? How we are using the mux as a universal logic circuit? This is the question. Okay, how we are using the mux as a universal logic circuit? You solve this by yourself. Okay, and if you have doubt, please feel free to ask in our telegram group. In our telegram group, okay, gate mantra. So I left this topic to you, how we are going to use the mux as a universal logic circuit. You first things and you try to solve, and after you have doubt, you ask in the telegram group, and there I will solve your query. Okay, so from next video we are going to see the more problems on this mux, or in 4 to 5, or in 4 to 5 lecture. Okay, in 4 to 5 lecture we are going to complete this multiplexer. Okay, multiplexer. Okay, and after completing this multiplexer we are going to start the demux. This will take only the one class or half class, and then we are going to see the decoder, and then encoder, and then we are going to see all type of adder, half subtraction, full header, full subtractor, and then ripple carry adder, and then look ahead carry, then ripple carry adder, then carry save adder, and carry look ahead adder. Okay, so all this adder and subtractor we are going to see in the last, first after completing this important topic, that is multiplexer, demultiplexer, decoder, encoder. Okay, thank you for this video. Thank you for attending the class.